On this 2014 to 2018 GMC Sierra 1500 with the 5.3 gas engine, P0113 is an intake air temperature sensor 1 circuit high voltage code. In plain language, the ECM may be interpreting the IAT sensor 1 signal as abnormally cold, which can line up with a high voltage condition on that sensor circuit. The truck may turn the cooling fans on when this code sets, and the concern can involve the sensor, the signal circuit, the low reference circuit, connector or harness issues, or in some test outcomes, the engine control module. Start with the basic system checks, and if other related air temperature, air metering, or pressure codes are present, check what they mean first. Then follow a structured diagnostic approach instead of jumping straight to a part. The IAT sensor 1 is a variable resistor in the multifunction intake air sensor. The ECM supplies 5 volts to the IAT sensor 1 signal circuit, and the scan tool temperature is the ECM's interpretation of that circuit. The scan tool display range is between -40 to +150 degrees Celsius, -40 to +302 degrees Fahrenheit. As quick circuit clues, a signal short to ground can show signal at 150 degrees Celsius, 302 degrees Fahrenheit. An open signal can show signal at -40 degrees Celsius, -40 degrees Fahrenheit. And a signal short to voltage can also show signal at -40 degrees Celsius, -40 degrees Fahrenheit. On the low reference side, an open low reference can show low reference at -40 degrees Celsius, -40 degrees Fahrenheit. And a low reference short to voltage can also show low reference at -40 degrees Celsius, -40 degrees Fahrenheit. For P0113, the important setting condition is this. The ECM detects the IAT sensor 1 signal is colder than -60 degrees Celsius, -76 degrees Fahrenheit, for greater than 5 seconds. Treat the running condition as a monitor gate. Once engine runtime is greater than 0 seconds, this monitor runs continuously when the gate is met. With the engine idling, look at the scan tool IAT sensor 1 parameter. It should be between -38 to +149 degrees Celsius, -36 to +300 Fahrenheit. If it is in that range, reproduce the operating conditions for the code. You can also reproduce the conditions captured when the fault was recorded. Then verify the code does not reset. If it does not reset, that path is all okay. If the parameter is outside that range, or the code resets during the drive conditions, move into circuit testing. For circuit testing, turn the ignition off and let all systems power down. It may take up to 2 minutes. Disconnect the harness connector at the B75C multifunction intake air sensor. First, check the low reference circuit. Test for less than 2 ohms between low reference circuit terminal 3 and ground. If that reading is 2 ohms or greater, disconnect the harness connector at the K20 engine control module and test the low reference circuit end-to-end for less than 2 ohms. If the end-to-end resistance is 2 ohms or greater, repair the open or high resistance in that circuit. If the end-to-end resistance is less than 2 ohms, the path calls for replacing the K20 engine control module. If the low reference circuit checks at less than 2 ohms to ground, turn the ignition on and check the IAT sensor 1 signal circuit. Test for 4.8 to 5.2 volts between signal circuit terminal 1 and ground. If the voltage is less than 4.8 volts, turn the ignition off. Disconnect the K20 engine control module connector and test for infinite resistance between the signal circuit and ground. If you have less than infinite resistance, repair the short to ground. If resistance is infinite, test the signal circuit end-to-end for less than 2 ohms. If it is 2 ohms or greater, repair the open or high resistance in the circuit. If it is less than 2 ohms, the path calls for replacing the K20 engine control module. If the signal circuit voltage is greater than 5.2 volts, handle that like a possible short to voltage. Be careful here, because if the signal circuit is shorted to voltage, the engine control module or the sensor may be damaged. Turn the ignition off, disconnect the K20 engine control module connector, then turn the ignition on. Test for less than 1 volt between the signal circuit and ground. If the reading is 1 volt or greater, repair the short to voltage on the circuit. If it is less than 1 volt, the path calls for replacing the K20 engine control module. If the signal circuit voltage is between 4.8 to 5.2 V, Look back at the scan tool. With the sensor disconnected, verify the IAT sensor 1 parameter is colder than -39 degrees Celsius, -38 Fahrenheit. If it is warmer than -39 degrees Celsius, -38 Fahrenheit, turn the ignition off, disconnect the K20 engine control module connector, and test for infinite resistance between signal circuit terminal 1 and ground. If resistance is less than infinite, repair the short to ground. If resistance is infinite, test the signal circuit end-to-end for less than 2 ohms. If that circuit is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the path calls for replacing the K20 engine control module. If the scan tool parameter is colder than -39 degrees Celsius, -38 degrees Fahrenheit, turn the ignition off and install a 3-amp fused jumper wire between signal circuit terminal 1 and low reference circuit terminal 3. Then turn the ignition on. Now the scan tool IAT sensor 1 parameter should be warmer than 149 degrees Celsius, 300 degrees Fahrenheit. If it is colder than 149 degrees Celsius, 300 degrees Fahrenheit, turn the ignition off. Remove the jumper wire, disconnect the K20 engine control module connector, and turn the ignition on. Test for less than 1 volt between the signal circuit and ground. If the reading is 1 volt or greater, repair the short to voltage. If it is less than 1 volt, turn the ignition off and test the signal circuit end-to-end for less than 2 ohms. If the circuit is 2 ohms or greater, repair the open or high resistance. If it is less than 2 ohms, the path calls for replacing the K20 engine control module. If the jumper test drives the scan tool parameter warmer than 149 degrees Celsius, 300 degrees Fahrenheit, the path points you back to the B75C multifunction intake air sensor. Turn the ignition off, disconnect the sensor connector, and test the IAT sensor 1 by varying the sensor temperature while monitoring sensor resistance. A thermometer can be used to test the sensor off the vehicle. Compare the resistance readings to the temperature versus resistance table for Hitachi sensors. The resistance values need to be in range of that table, so do not substitute generic IAT values. If the readings are not within the table values, replace the B75C multifunction intake air sensor. If the readings are within the table values, that path is all okay. After any wiring repair, sensor decision, or module decision, keep verifications separate from the testing. Run the vehicle back through the operating conditions that set the fault, verify the repair, and confirm P0113 stays gone. The takeaway is simple. Prove the low reference first. Prove the signal circuit next. Simulate the sensor response with a fused jumper, and only then make the sensor or module call. For more diagnostic training, visit stepdiagnostics.com.